Guys, today's video is on greatest common factor. Factoring is basically reverse distribution. So for example, if we distributed this a times 3a, we would get 3a squared, and then a times 7a, or a times 7, excuse me, is a 7a. Whereas factoring is doing the opposite. Here we have 3a squared plus 7a, but we're going to go backwards to what's called the factored form pre-distribution. If we cannot make a factored form in parentheses, we call that prime. If you cannot take out any factors. Let's use some examples. Well, before we do examples, we need to just go over the steps for factoring and finding out the greatest common factor. Step 1, you are going to identify the GCF. The GCF is made up of two parts, the GCF of the coefficients and then the GCF of the variables. We'll talk about how to get the GCF of variables. I'm pretty sure you guys know how to do a GCF of coefficients. The second step is you're going to divide each term by that GCF you took out. And you're going to leave the remaining factors in parentheses. And then step 3, always check your work through distribution. Okay, let's go on and do some easy examples, get a little bit more difficult with this factoring. Start with number 1. Number 1, the GCF of the coefficients, 3 and 12. The biggest number that goes into 3 and 12 with no remainder is 3. The next thing, do they both have variables that they have in common? They do not. This one has an x. This term does not. So we can now divide both terms by the GCF that we took out. Just the 3. If we divide the first term by 3, we're left with x. And then dividing the second term by 3, we're left with 4. Here's your answer, but we also need to check our work to see if we got the right answer. We can distribute, and we would get 3x plus 12, which is the beginning answer, which is correct. Let's go on to a little more challenging one. Look at the next page. Let's look at number 6. Number 6, we first need to find the GCF of the coefficients. The coefficients are 4 and 24. Don't worry about the negative right now. Those GCF, the biggest number that goes into 4 and 24 is 4. Next, we look at the variables. They both have y's, so we're going to take out a y. You always take out the smallest exponent y. Here, this has an exponent of 2. This has an exponent of 1. The smallest one is regular y. And then lastly, what you have to do is divide each term by what you took out as the GCF. Here we're going to divide each term by 4y. Dividing the first term by 4y, the 4's cancel, and we're left with y. And dividing 24y, divided that by 4y, makes a negative 6. Check your answer through distribution. If we distributed here, we would end up with 4y squared. Oops, let me pick a different color. 4y squared minus 24y through that distribution, which is correct. Let's do one with multiple variables to find the GCF. Let's look at number 9. Number 9, we need to find the GCF of 15 and 30. Start with your coefficients. The biggest number that goes into 15 and 30 is 15. Next, we have to look to see if they share variables. They do share a's, but remember we take out the smallest a. The smallest a is an a to the first power. Now let's look at the b's. This one has a b and this one has a b. So the smallest b we can take out is just a normal b. And now we divide both terms by what we took out. We're going to divide both by a 15ab, divide that by a 15ab. The first term, you're just left with an a because the b's cross out and the 15s cross out. The second term, you have a -2 because 30 divided by 15 is 2. And the a's and b's also cross out. Check your work through distribution. Questions so far, write them down. Let's go on to one with 3 terms. Let's do maybe 15. So we got a 2 coefficient, 2, and a 4. The GCF of all 3 of those, the biggest number that goes in all 3 is a 2. Do they all have x's? Yep, they all do have x's. So the smallest x we're going to take out is just a 1x. And then let's see if they all have y's. Yes, they all did have y's. If 2 of them had a y and 1 didn't, you would not be able to take it out. So we can take out a y. The smallest y here is a y to the 1. And then lastly, we divide each term by our total GCF. And we write that in parentheses. This first term, we're left with x. The second term, the 2's cancel, x's cancel, and we're left with a -y. And lastly, the x's cancel, y's cancel, and we're left with a +2. Check your work through distribution. Let's just do one more together. Let's pick a good one. Let's pick number 22. Number 22 says we have 3 terms again. The GCF of 16, 20, and 8, the biggest number that goes into all of them, I believe is 4. Now to check, do they all have x's? Do they all have x variables? No, they do not all have x's, so I can't tag an x. Next, do they all have y's? This one does, this one does, and this one does. So we will take out one y, since that's the smallest exponent. Next, divide each of these terms by 4y. See what you would get. Check it with me. You do get 4xy. Looks like you need a little bit more space. Plus 7x, since the y is canceled in the middle term. Plus 2, and the y is canceled there. Check your work through distribution. Write down any questions you have. There you go, greatest common factor. Very important stuff for this next unit, and have a great night.